Okay, a limit question. We're looking for the limit of this function. Now, if it happens to be positive or negative infinity, we'll go ahead and say that, even though that doesn't really exist. Notice that we've got radicals in the numerator. We don't want to go ahead and just plug a 0 in for h. We would end up with the indeterminate form. So let's rationalize the numerator. We'll multiply by the same terms with the opposite connector. We'll do the same thing to the bottom. Okay. Well, now up top I've got lots of distributing to do. Down low I'm going to leave that in factored form. So I need to use FOIL up top. That is, I'm going to multiply the first together. So when we multiply the square root of something times the square root of the same thing, well, that's actually the square root of 2 of them. Well, wait a minute. The square root of 2 of them, you need 2 of them to take 1 out of that radical. Okay, well, that just means that x plus h comes right out. Let's clean this up and show it. When we multiply our first, we've got just x plus h. When we multiply our outers, we have a positive. The roots are a match. Underneath, we'd have x times x plus h. But you know what's about to happen. The inners, that's a negative times a positive. Same things, x times x plus h. And the last, a negative times a positive, makes a negative. The square root of x times the square root of x is the square root of x squared. What that means is that we can take out just an x. And the bird says hi. Now then, the bottom, we're going to leave that in factored form. We've got h times the quantity, square root of x and h, and the square root of x. Oh, I have a lot to clean up. Okay. These outers and inners, they're opposites. They're gone. Even this x and that minus x, they're gone. Let's see what remains. When we clean this up, we've got the limit as h approaches 0 of h divided by this big old mess in the bottom. Now, it is appropriate for us to cancel between top and bottom since the bottom is written as a product. When we do, we have just 1 up top. So this is the limit as h approaches 0 of 1 divided by the quantity, the square root of x and h plus the square root of x. I've done as much as I possibly could to simplify this expression. It's time for us to go ahead and plug that 0 in for h. That's 1 over the square root of x plus 0. Add to that the square root of x. Well, that's the square root of x plus the square root of x. Those roots and radicands match. We've got 2 of the same thing. Now, this is a fine version. We could instead rationalize the denominator, but I think I'll just quit while I'm ahead. So our limit as h approaches 0 is 1 divided by 2 square roots of x. Ta-da!